Okay, we're ready to do our last section for Chapter 1. So this is it for the Chapter 1 test as far as material goes. So Section 1.7 gets into solving linear inequalities. So we've done a lot of equations so far. Now we're going to look at some inequalities. Okay? And so there are guided notes for this if you want to download them and use those, or you can just use notebook paper. So example 1, it asks us to graph the solutions for each of these inequalities. So the first one they give you is x is less than 3. And in addition to graph, I'm actually going to ask you to do one more thing here. I want you to graph this, and I also want you to write your solution in what's called interval notation. So you may or may not have done interval notation before, but it's going to come up a lot in this and then really in the next chapter. So let's do a little practice with that. First, let's talk about graphing this. The solution to this is a number line inequality. This represents all numbers, all real numbers, that are less than 3. So x is less than 3. We want all numbers that are less than 3. So we're going to draw a number line, and I'm not so picky about where you put the number line or what you put in the middle. Some people like to put 0 in the middle just to split the negative and the positive numbers. You can leave that off, or just put 0 and then put 3. 3 is the number we want to stop everything at. So I'm going to put 3 to the right side. You can just put 3 on it. I'm not real particular about how you do it, but what I do want you to get in the habit of doing is shading correctly. So we want all numbers less than 3. So we want numbers that are less than 3, so that would be to the left of x equals 3. So I'm going to shade all of this in. Do the best you can with your shading. And then we want to show that we want all numbers up to, but not including, the number 3. So to show that, I'm going to use a parentheses. Now, in high school, you may have used an open circle or a filled-in circle. Same thing, same idea. And if you use it on a test or something, that's okay. But I'm going to use the parentheses, and you'll see why, because that goes right along with the interval notation. So interval notation is essentially a representation of this number line in symbols. And so I want numbers that are all less than 3, and this goes all the way down to negative infinity. So when you write an interval notation, you want to always go from the lowest to the highest number. So my lowest number, there is no lowest number, it goes down to negative infinity. So I'm going to put negative infinity, and then negative infinity always has a parentheses around it, and then up to the number 3. Now, we don't want to include the 3, so the way we represent that in interval notation is we use a parentheses. If we wanted to include the 3, we would use a bracket, but since we did not, we're going to use a parentheses. So this is the interval notation representation for what we have here. So x is less than 3 is the inequality. This is the graph. This is the interval notation. Let's do the same thing with letter B. So letter B, they want you to work with x is greater than or equal to negative 1. So let's do the number line first. So I'm going to draw my number line, and I'm just going to put negative 1 somewhere down on this end. So we want all numbers that are greater than or equal to negative 1. So everything bigger than negative 1. So think about which way you're going to shade. Which direction would numbers larger than negative 1 be? And hopefully you said to the right. These would all be numbers bigger than 1, negative 1 rather. Now, do we want to include negative 1 this time? Yes, we do. Remember that this is greater than or equal to. So I'm going to put a bracket to designate that I want to include it, and I'm going to make the bracket go in the direction of my shading. Okay? Interval notation. So the lowest value in my interval is negative 1. So I'm going to put negative 1, comma, and I want to include the negative 1 this time, so I'm going to put a bracket around it. Is there a highest value in my shading here? No, this is just going to keep on going to positive infinity. And infinities, negative and positive, always take parentheses when you write those in interval notation. Okay? Last part of this example is letter C. So they want us to do the same thing for the inequality negative 1 less than x less than or equal to 3. Let me make sure I've got that. Yep, that's what I think you have in your notes. So let's start with the number line. So I'm going to put negative 1 somewhere on this end, and I'm going to put positive 3 on this end. So this is what's called a compound inequality. My solution are all of the numbers that are greater than negative 1 and at the same time less than or equal to 3. So I want everything in between -1 and 3. So I'm going to shade in between -1 and 3. Do I want to include -1 here? No, I do not, because it's just at -1 is less than x, or x is greater than -1. So I'm going to put a parenthesis on that end to designate that. And then at 3, do I want to include it? Yes, I do, because it's x is less than or equal to 3. So to designate that, I'm going to put a bracket on that end. Interval notation, so my lowest number is -1, and I did not want to include that, so I'm going to put a parenthesis around it. My highest number is 3, and I did want to include that, so I'm going to put a bracket around it. So there you have it. That's inequality notation. This is the graphical notation, and this is the interval notation. All right, so the next example, they want us to actually do a little bit of algebra here and solve this inequality. So we have 4x plus 5 is less than or equal to 9x minus 10. So you're going to solve this just like a normal equation. We want to combine any like terms, do any distributing if we can, and we want to get all of the x's to one side and all of the constants to the other. I tend to prefer to have the x's on the left side when I solve these inequalities. I think it makes the inequality easier to read. So I'm going to put the 9x on the left side with the 4x. So it's positive 9x, so I'm going to subtract it to get it to the other side. So I have negative 5x plus 5 is less than or equal to negative 10. And then I need to get that 5 over there with the negative 10, so I'm going to subtract 5 from both sides. So I have negative 5x is less than or equal to negative 15. Now I need to get the x by itself, so I'm going to divide by negative 5. And you may remember this little caveat: when you divide or multiply by a negative number, it doesn't matter what the number is that you're using, but when you multiply or divide by a negative number, you have to flip the inequality sign. So instead of being less than or equal to, it's going to now turn into greater than or equal to. Negative 15 divided by negative 5, of course, is 3. So my solution to this inequality is x is greater than or equal to 3. Let's go ahead and do the number line representation of this, and then we'll do interval notation as well. So I'm going to just put 3 somewhere over here on my graph. I want all numbers that are greater than or equal to 3, so I'm going to shade to the right. And it's greater than or equal to, so I'm going to put a bracket around the 3. Think about what this would be in interval notation. I want my lowest bound to be 3, and I want my highest bound to be infinity, because it's never going to stop. It's an open-ended inequality. Infinities always take parentheses around them, but this was greater than or equal to 3, so it had a bracket there, so I'm going to have a bracket there. And that's our solution. Let's take a look at example 3 in the notes. So this time they're asking us to solve a compound inequality. So we have negative 3 is less than 2x plus 1, and that's less than or equal to positive 3. So there's our inequality that we want to solve. And so we're going to solve this by, of course, we always want to isolate the x. So I'm going to go ahead and I want to get this x by itself. I need to move the 1 first. So I need to subtract the 1. And what you're going to do is you're just going to subtract the 1 from all 3 sections. Like so. So those 1s will go away. Negative 3, negative 1 gives me a value of negative 4. Less than 2x, less than or equal to 3 minus 1, which is 2. And then we need to divide by 2. Got to do that to all 3 sections. So I have negative 2 less than, of course those 2 go away, I just have an x, less than or equal to 2 divided by 2 is 1. So this is your solution, your intervals, or your inequality version of your solution. Let's go ahead and do a number line. So I have a lower bound of negative 2, an upper bound of 1, and I did not want to include the negative 2, so I'm going to put a parenthesis on that end. I did want to include the 1, so I'm going to put a bracket on that end, and we want everything between the 2. So this compound inequality means I want all my solutions to be between negative 2 and positive 1, not including negative 2, but including positive 1. What would this look like in interval notation? So my lower bound would be negative 2. We did not want to include it, so we're going to use a parenthesis, comma, my upper bound would be 1, which we did want to include, so I'm going to use a bracket. Okay, so the next section in the guided notes is asking you to take a look at absolute value inequalities. So basically an inequality, but it has an absolute value in it. So to solve this, there's a little bit more going on because there's two cases that you have to consider. All right, so let's look at this. We're looking at absolute value inequalities. All right, and so let's look at the first case. If we have the absolute value of some expression, and that's greater than c, what we're going to do to solve that is we're going to drop the absolute value, and we're going to write it as what's called a disjointed inequality. We're going to say x, or whatever's in the absolute value, is less than negative c, or x is greater than positive c. We'll do an example of this so you can see what we're talking about. Let me go through this again. So if we have the absolute value of some expression is greater than a number, c is a number, okay? Greater than c. This is called the or case, if you want to think of it that way, okay? If that happens, we're going to take what's in the absolute value, we're going to drop the absolute value, and we're going to make two separate inequalities. We're going to say whatever's in the absolute value is less than the negative c, the negative of whatever that constant is, or whatever's in that absolute value is greater than the positive c. So on the number line, they would be going in opposite directions. So negative c would be here, positive c would be here. You'd be talking about this end down here, or this end up here. So you'd be talking about two separate disjointed inequalities, or two separate regions. So that's the or case. Greater than is the or case. That's kind of how I remember it. The second case is if we've got the absolute value of some expression is less than a constant c. So this is the and case. So when it's this case, this is when you're going to have a compound inequality. And so we're going to rewrite what's in the absolute value, whatever it is, and we're going to make it greater than the negative c and less than the positive c. So this is the opposite case we just had. Your solution is going to be all the numbers between the negative c and the positive c. So what would this look like on a number line? So if we had negative c here, positive c here, we'd be talking about everything in between the two. So just study that for a second and make sure you know these cases. So you're either going to have a greater than case where they're going to be going in opposite directions, or the less than case, the and case, where they're going to be going together as a compound inequality. So let's take a look at example 4. Example 4 is an example of what we're talking about. So in this example, we have the absolute value of x minus 4 is less than 3. Okay, so this is a less than case. So think about which of the cases we just talked about. This expression in the absolute value is less than the constant 3. So we're looking at case 2 here. So to solve this, I'm going to drop the absolute value. I'm going to take what's inside, and I'm going to sandwich it between the negative 3 and the positive 3. And then we're going to solve that like we did a few minutes ago. So I need to get the x by itself. I'm going to add 4 to both sides, add 4 to both sides. Negative 3 plus 4 is 1. Of course, this goes away, so I just have the x in the middle, and then 3 plus 4 is 7. So my solution to this would be all numbers that are between 1 and 7. Let's go ahead and graph this on a number line. So 1 would go there, maybe 7 would go there. There was no equal to, it was just less than and less than, so we're going to go ahead and use parentheses for both of these, and we're going to shade in between. What would the solution look like in interval notation? It would be 1, 7, and both would have a parentheses. All right, let's take a look at example 5, and let's see what kind of case we need to use for that. So example 5, we've got absolute value of 2x plus 3 is greater than or equal to 5. Okay, so which case is this? We've got greater than. Now the or equal to doesn't make a difference. It's the sign of the inequality that you're looking at. It's the same thing. It's still going to be case 1. This is our or case. So what that means is, go back and look at your notes. I'm going to take what's in the absolute value, that expression, and I'm going to make two separate inequalities. So I'm going to say 2x plus 3 is less than or equal to the negative of that value, so negative 5, or my solution is going to be on the other end of the number line, and 2x plus 3 is going to be greater than or equal to the positive 5. Okay, so we're going to have two different inequalities, and we're going to solve them independently. So over here, I'm going to subtract 3 from both sides. So I have 2x is less than or equal to negative 8. Divide by 2. And then I have x is less than or equal to negative 4. So that's half of my solution. Let's come over here and solve the other inequality. So I'm going to take away the 3. So I have 2x is greater than or equal to 2. And I'm going to divide by 2. And I have x is greater than or equal to 1. Okay, so my solution, we'll put that word or in there, it's x is less than or equal to negative 4, or x is greater than or equal to 1. Let's look at what this looks like on the number line. So I've got negative 4 on this end, I've got positive 1 on this end. I'm going to put, they both are going to have the brackets because of the or equal to. You just kind of follow that through in the problem. And so let's put a bracket here. Let's put a bracket here. And so I want all the numbers that are less than or equal to negative 4. So that would be on this end. And then I want all the numbers that are also greater than or equal to 1. So notice the inequalities go in opposite directions. That's what should happen with that or case. Let's see what this looks like in interval notation. So down here, the lowest bound would be all the way down to negative infinity. Comma, remember infinities always take parentheses. Negative 4 with the bracket. And then to signify the or, we use a union. So union, then we got to pick up on the other side. So I'm going to go from 1 up to positive infinity. And that's going to be my solution in interval notation. So there's the inequality solution. There's the number line solution. There's the interval notation. At the last example here for this section. So we're doing another absolute value inequality. This time we have negative 2 times the absolute value of 3x plus 5 plus 7 is greater than negative 13. So the one difference here is that the absolute value is not by itself to begin with. You've got to isolate the absolute value before you try to figure out which case it is. So to solve for this absolute value, I'm going to subtract the 7. So I've got negative 2 times the absolute value of 3x plus 5, and that's greater than negative 20. And then I need to get rid of that negative 2. Of course, you can't distribute it, so I have to divide it over to the other side. And if you'll notice, I'm dividing by a negative number. So what does that mean for the inequality? So I'm going to have to flip the inequality because I'm dividing by that negative number. So instead of being greater than, this is going to be less than 10. Negative 20 divided by negative 2. Now that I've isolated the absolute value, look at which case it is. This is less than, that's the and case, so it's case 2. So I'm going to take what's inside the absolute value, and I'm going to rewrite it by sandwiching it between the negative 10 and positive 10. And then we're going to solve that inequality. So I'm going to subtract 5 from all three sections. So I have negative 15 is less than 3x, and that's less than 5. And then I'm going to divide everything by 3. So we end up with negative 15 over 3, so we have negative 5 is less than x, which is less than 5/3. So that's our solution in inequality notation. Let's go ahead and put it on a number line. So I'm going to have negative 5 on this end somewhere. I'm going to have 5/3 on this end. It's all going to be parentheses, so parentheses, parentheses, and we're going to shade. We want our solution to be everything in between. What would this look like in interval notation? We would go negative 5, comma, 5/3. Negative 5 is the lower bound, 5/3 the upper bound, and they both took parentheses. So this is inequality notation, this is graphical notation, and this is interval notation for our solution.